Hi, I'm Hal Weber with Eiffel Software, here this time to tell you a little bit about how Eiffel relates to people, organizations, and other software development methods and languages. This first presentation is an introduction. It's followed by separate presentations that address Eiffel's place next to other specific technologies like Java, C#, and UML. Once you've completed the introduction, you can view any or all of the more specific presentations. So in this first talk, I want to cover three things. First, a bit about the people who use Eiffel, particularly how and why they got here. Then I'll discuss some of the most profound ways in which Eiffel differs from all other development technologies. And finally, I want to talk some about the uninformed opinions of Eiffel that you may hear tossed about. You should feel free to use the navigation controls and skip around some if I get to droning on about something that just doesn't interest you. For example, if you have only technical interest, you might want to go lightly on the human and managerial issues in the first and third sections and concentrate more on the technical stuff in section 2. With that in mind, let's get started. As you probably know by now, my job, primarily, is to teach people to produce better software and lower their software costs at the same time through the application of the Eiffel Development Framework. And also, I hope to show them that they can have a good time while they're doing it. When I began preparing this series of presentations, I spoke to an old friend who teaches computer science at the local university and uses Java in his research. I asked him if he would be willing to review for accuracy my presentation about Eiffel and Java, and he agreed to do this. During the discussion, I accused him of being well versed in Java, and he replied that he used Java mostly because, apart from C++, it was what he knew. And then he said, "I guess we become married to our tools." And I think he's right. We remember the frustration we felt when first trying to use tools and languages with which we were unfamiliar. But once we become fluent with a tool set, we become comfortable. Then if we're presented with some particular problem, we tend to formulate solutions within the context of our ability to use our tools and the capabilities of our tools themselves. If, as my friend says, we become married to our tools, does that put me in the awkward position of being a bit of a home wrecker, out to destroy the wedded bliss between you and Java or Delphi or C#? Well, maybe to some extent. I certainly want you to see enough of the advantages that Eiffel has over these other tools, that you'll stay intrigued about Eiffel and continue to pursue Eiffel fluency. But in the meantime, you don't need to sever your relationships with other methods and tools. Eiffel is open and works well with software created through other means. And just to exploit the marriage analogy, maybe beyond the limits of good taste, as far as I know, software development polygamy is not a criminal offense. So who are these people who use Eiffel? When we teach Eiffel classes, we find that almost all the engineers who attend already have practical knowledge and experience in some other development methods and/or languages. So how do these people end up enrolled in an Eiffel class? Well, almost always it starts with someone reading object-oriented software construction, or one of Bertrand Meyer's many other publications, or possibly hearing Dr. Meyer speak. They find the message intriguing, and they come to think that maybe the software development pitfalls that they've always accepted aren't as inevitable as they had previously believed, and that Eiffel has advantages worth looking into. Some of our students have been encouraged, coerced may be a better term, by their management to attend the Eiffel course. Their managers see the potential value of Eiffel and guide their engineers in that direction. These managers often have significant technical background, and of course we at Eiffel Software would credit them as being visionaries as well. But most of our students have signed up willingly, even eagerly. Often Eiffel awareness starts at the grassroots of an organization and spreads outward and upward. Some individual or group will see that the Eiffel method makes a lot of sense, and they try it out. And although these first projects may not ever show up in the Eiffel Hall of Fame, still they're so far ahead of the organization's traditional methods that their results are hard to ignore. In the Eiffel Development Framework presentation, I told you about a company that constructed a new server system with Eiffel. Then they needed to create a new client to that server. When the client was complete, it contained only 18% new lines of code. All the rest were reused, in place and unmodified, from the server project. This type of savings would have been impossible with the organization's traditional standard technologies, which had been oriented toward reuse only in the sense that old modules were occasionally copied and hacked to make new ones, and measuring any kind of reuse results was completely out of the question. So ask yourself this: how well is your organization doing in reducing costs by reusing the software assets you create using your current technology? What evidence do you have to support your answer? Wow, okay, so these sound like test questions from one of those professors that I didn't like very much till I finally got out of their course. But the point is that most Eiffel people can answer these questions, because Eiffel makes it possible. So almost every Eiffel programmer got to be an Eiffel programmer after having first been some other type of programmer. And almost every Eiffel programmer I know is passionate about the advantages of Eiffel. I have yet to meet a programmer who had been competent in Eiffel and then changed by choice to some other tool set because he or she thought that tool set provided a better way to build software. It just doesn't happen. When Eiffel people introduce Eiffel into their organizations, sometimes it's easy, but sometimes introduction of a different technology, no matter how far superior, is met with resistance. Mostly I think this is due to the normal human resistance to change, and to that marriage-like relationship that I spoke of earlier that we nurture with our current technology. And it's understandable. People have worked hard to develop fluency in their tools, and they don't want to go back to that frustrating feeling of not knowing how to do stuff. But our customers have found that the adoption of Eiffel lessens these frustrations, because Eiffel is so easy to learn and works so well with other technologies. Here's another thing I've noticed about people who use Eiffel. They tend to be smart and resourceful. Now, I don't mean to imply that people who use other technologies are not smart and resourceful, nor do I mean to imply that using Eiffel will make you smart and resourceful. It's just something that I've noticed, and I've tried to understand why. Let me try to explain. Periodically, there's a meeting of Eiffel people. It's called the Eiffel Summit. Eiffel people come from all over the world to share their experiences with one another. I've been lucky enough to attend several of these. The presentations usually show Eiffel being used to solve very complex problems, or even not so complex problems in very elegant ways. After one Eiffel Summit a few years back, I had dinner with a fellow who had a similar development background to me, typical corporate information technology among other things. At one point, this fellow says, "Did you notice that all those people at the Eiffel Summit are brilliant?" And then he asks, "Where are all the ordinary people?" Well, I had noticed it, but I hadn't thought about it much until he pointed it out. In fact, always at Eiffel Summit, I seem to be surrounded by people who make me feel like I've got an IQ that would register somewhere between geranium and toad frog. And I think that's really a paradox, and here's why. If you've been listening to my other presentations, you've heard me say that Eiffel is simple and elegant, easy to learn, easy to manage. With Eiffel, it's much easier to build high-quality solutions to most problems than it is with other technologies. So Eiffel seems ideal for ordinary people like me and my friend from Eiffel Summit. We are, to borrow an expression from Grady Booch, the great unwashed masses. And yet often the people who are taking advantage of Eiffel are not the great unwashed masses. Rather, they are people who probably are smart enough to do their jobs fairly well the hard way with other technologies if they wanted to. So how did things get this way? I'm not sure, but I've got a hunch or two. I think part of the problem is that software is so tricky that once we find something that works, we tend to continue to use that same tool or technique over and over. And there's not really anything wrong with that, except that there could be better ways to do things that we may miss out on if we don't constantly evaluate our own needs against currently available methods and tools. And in the most extreme cases, we might really lose out if we blindly follow other engineers or vendors or consultants. Once I was on the engineering staff of a company whose management made a decision to buy and implement a multi-million-dollar piece of off-the-shelf software. At the announcement, one of the engineers asked, "How do you know this is the right thing to do?" The manager answered, We know it's the right thing to do. It's what our toughest competitor is doing. So my company was just blindly following its competitors rather than really trying to understand its own needs and options. And I think another reason that the Eiffel Summit tends to make me feel like Homer Simpson at a Mensa convention is that many of us ordinary folks are more easily satisfied with the status quo. We tend to say stuff like, I know what I have to do to make it work, rather than asking the questions like, why on earth do I have to do that to make it work? Often we don't go looking for methods and tools other than the ones that are presented to us by our managers, our peers, or the companies who publish the operating systems we use. So Windows programmers tend to use Visual Basic and C++, now C#. Many Unix users use C, C++, and Java. Eiffel Software is not in the business of building operating systems, although an operating system developed using Eiffel has been a persistent topic of discussion. Anyway, to find us, people usually have to come looking for us because they're not satisfied with the status quo and are seeking a better way. And as for you, well, you found us. You have both our thanks and congratulations. Next, let's see some of the ways in which Eiffel is different from all other software development technologies. At the risk of belaboring a point that you've probably heard me make many times, the first difference between Eiffel and all other development technologies is that Eiffel is a complete development framework, something that can't be said of Java, C#, Visual Studio, C++, Delphi, UML, or any other method or tool or language that I know of. You can't really use C# to design systems, like you can't really build fully implemented systems in UML. You can do both of these things with Eiffel. Okay, enough said about that. What else? Let's look at some other really important items in general terms. Because Eiffel is a complete framework for software development, and because it's designed for consistent support for all development phases, you get true round-trip software engineering. You see, in Eiffel, there's really only one type of product, the software. But there are lots of ways of viewing that product, depending upon which hat you happen to be wearing at any given time. As a consequence, any change that you make in any editable view will be immediately visible in all other views in which the change should be visible. So if you're working at a fairly high level with a diagram, for instance, and you make a change, that change would immediately be seen in the software text of the affected class or classes, and vice versa. With Eiffel, there's never any need to regenerate code or diagrams. How about multiple inheritance? Multiple inheritance is really a good thing that suffered from a lot of bad press. Smalltalk never had it. Eiffel has always had it. C++ originally didn't have it, but it was added later. And this is when the troubles began. The C++ implementation of multiple inheritance used a sub-object model and provided no facility for resolving member naming issues. This meant that multiple inheritance had to be used with extreme care in C++, especially in cases in which repeated inheritance occurred, the so-called diamond of death. Many C++ instructors and textbooks either discourage the use of multiple inheritance or issue stern warnings to be careful. So multiple inheritance in C++ is not something for the great unwashed masses. As a result, the designers of Java, apparently deciding that C++-style multiple inheritance was more trouble than it was worth, chose not to make it available in Java. And the C# designers followed suit. Instead of fixing the problems with C++-style multiple inheritance, they provided a similar but much less functional facility called interfaces. But the problem isn't really with multiple inheritance itself, but with its implementation. In Eiffel, it's easy and safe to create a new class as an heir to multiple fully or partially implemented parent classes. This means it's easy and natural to combine abstractions. It's no problem because Eiffel doesn't assume the sub-object model, so there's no diamond of death as in C++. There's no need to cripple parent classes into interfaces as with C# and Java. And Eiffel's ability to adapt parents' features in the heir class can resolve any feature naming problems that arise. At the end of the day, the full multiple inheritance in Eiffel means that what you discovered during analysis has mapped more directly into your software product, so the software more closely reflects the problem domain. And of course it leaves out layers of engineering and duplicated code caused by Java-style interfaces. It gets your job done faster with fewer opportunities for mistakes, at the same time providing you with more opportunities for software reuse. All these are benefits of full, safe, controllable multiple inheritance, and no other commercially viable product offers this. Another major difference between Eiffel and the rest of the world is design by contract. If you've viewed the design by contract presentations already, you know what it's all about, but here are the high points. Design by contract lets you specify what your software does in a clear and unambiguous fashion, but separate from the software's implementation, so it separates what it does from how it does it. It includes this specification in your software product, so when you consider a module for reuse, you know exactly what it does and what's required for you as a reuser. Because the specification is part of the software, your software can be checked for compliance to the specification at runtime, and this provides the very best model for exception handling. The obligations for you and your software are clear. Now on to what I really wanted to say about design by contract. I want to point out that without design by contract, Eiffel could not provide good support for analysis and design. Design by contract is used to express and record the natural constraints that we observe in a problem domain during analysis, and these constraints eventually become part of the specification of a running software system. Programming languages like Java and C# have no integrated design by contract facility. Their role is limited to imperative programming. They cannot be used effectively as tools for analysis and design. In Eiffel, contracts are part of the method and language, so the information you record during analysis and the behavior decisions you make during design all eventually team up to become a self-checking, running software system. There have been some efforts to try to retrofit other methods and languages with design by contract type facilities. But with these, the contracts seem to be hung on as afterthoughts. Eiffel is the real deal. Eiffel contracts participate actively in the client-server and inheritance relationship supported by the Eiffel method. Eiffel is the only place you get this. Automatic documentation generation is another area in which Eiffel stands above other tools. Other environments have come a long way in documentation generation. If you're a Java user, you've seen that Java docs can do a pretty respectable job of producing documentation for the web. Likewise, with C#, embedded XML can be used to include extractable documentation information that can be made to show up nicely in Visual Studio.net. But I would argue that Eiffel documentation generation is superior for several reasons. First, and most importantly, the Eiffel documentation comes naturally from the software itself. So unlike Java docs and the C# XML, you don't have to put anything into your code that you wouldn't put there anyway. As a result, your code doesn't get cluttered with special annotations that are there just for the sake of documentation extraction. Eiffel can work in this fashion, 1, because it's designed to include naturally all the elements necessary for good documentation, and 2, because of the presence of design by contract. Many documentation views are targeted toward helping the viewer understand what a software element does. In Eiffel, you've already defined that in the software's contract, so it usually isn't necessary to add a lengthy explanation just to be extracted into documentation. Another thing that makes Eiffel documentation generation great is that you can choose from over a dozen formats in which to generate. So for paper deliverables, you might choose RTF, but to share with project members, you might choose stylesheet-based HTML. Next, during the course of the software lifecycle, it will be necessary at different times to view the software in different ways. These different views are all supported in the Eiffel online tools and by documentation generation. Lastly, formats which allow hypertext linking, like HTML, will be fully linked, so it's easy to see definitions and to follow dependencies. For example, if you've generated HTML documentation with diagrams, then you can click on a class oval in the diagram, and the link will take you to the class's definition. Okay, now that we've established that Eiffel is different in important ways, let's address some of the more common misinformation about Eiffel. Recently, I was offered the opportunity to speak to a local technology group about Eiffel from Microsoft.net. The leader of this group is part of a small, commercially oriented software development company. Concerning Eiffel, he said, "All I know about Eiffel is that it's an academic language." Yeah, we hear that one a lot, and it's wrong, for two reasons. First, as you know by now, Eiffel is a framework for software development. It has a full lifecycle development method. The Eiffel method is supported by a notation that we call Eiffel the language. The notation just happens to be designed such that when it contains sufficient detail, it can be compiled into a running software system. So it's really not right to look at Eiffel as only a language. Secondly, I'm not sure what academic language means, but if it means only used in the academic setting, or not fit for practical work, then this could not be farther from the truth. It is true that Bertrand Meyer, who developed the original Eiffel ideas, has academic background and is well respected in the academic community. It's also true that many of those Eiffel ideas evolved from work that was done by other academic computer scientists and mathematicians. And it's true that many colleges and universities use Eiffel to teach the best practices of software development. But Eiffel is also used successfully in many commercial and government endeavors. If you have any doubts, go to Eiffel.com and check out the success stories and customer endorsements. But don't do that now. Instead, let's examine this myth that Eiffel is not fit for practical work. Occasionally we've heard people say that Eiffel is only suitable for toy systems. This could not be farther from the truth. As I've said before, we see Eiffel being used in situations in which other technologies fail. If anything, it's the other commonly used technologies that tend to break down under stress. We see Eiffel being used instead of other technologies for systems in which scalability and reliability are essential. One of our customers is an organization that has developed a payroll system using Eiffel that every week pays over 200,000 employees in 20,000 different organizations. These people would assure you that Eiffel is indeed industrial grade. So is it true that not many people use Eiffel? Well, maybe the answer to this depends a bit upon your frame of reference. A couple of years ago, Microsoft estimated that there are 20 million Visual Basic programmers worldwide. If this is true, then relatively speaking, we must have to admit that Eiffel's market share is considerably smaller than that of Visual Basic. Despite that, I don't think it's correct to say that not many people use Eiffel. Eiffel licenses worldwide number in the tens of thousands. If you use Eiffel, you're not alone. These license holders have formed a lasting worldwide quorum. Many world-class organizations are committed now and will continue to be committed to the Eiffel framework. Their support through your maintenance contract with Eiffel software, help and information are available online in the form of the Eiffel users list and comp.lang.eiffel. So don't worry about it. Plenty of people use Eiffel, and those numbers are increasing constantly. Through the years, some potential customers have expressed to us a concern that if they embrace Eiffel, they may not be able to find a sufficient number of qualified developers. This is, of course, incorrect. I told you earlier that almost all Eiffel people were proficient in some other technology before they became Eiffel people. Now, it turns out that this really works to your advantage. You see, Eiffel people want to stay Eiffel people. So an Eiffel programmer on the job market will be searching for an Eiffel position first, and would probably rather have a root canal than to go back to working in his or her previous technology. It's important also to understand that Eiffel developers are easy to create. Because Eiffel is simple, clean, and elegant, it doesn't take people long to get going with it. I teach a 5-day course that contains 15 programming exercises. Each time I've taught the course, almost every student has finished every exercise. Students leave with a good foundation on how to begin saving time and money for their organization by constructing quality software with Eiffel. These people can be fluent in Eiffel in as little as a couple of months. This can be contrasted with the other extreme. A well-known Microsoft Windows expert told me a couple of years ago that he estimated it took 5 to 7 years to become truly fluent in C++ on Windows. Programmers who are proficient in other technologies often experience Eiffel as a breath of fresh air. How about this one? Eiffel might not be around in 5 years. Well, I think the first time I heard this one was about 1989, and of course I've heard it many times in the years since. And of course, it's not true. Look, Eiffel is more complete and functionally superior in most ways to every other commercially available software development technology. And there are enough people around who recognize this, that quorum of users I spoke of earlier, to ensure that Eiffel will be around for a long time to come. It's possible that 25 years from now there'll be a significantly better idea, but certainly there hasn't been anything to come close since Eiffel's original design in 1985. In most areas, other technologies are still playing catch-up. Don't worry about it, Eiffel will be here. In this presentation, I've tried to give you a little bit more feel for the Eiffel culture and the people who live there, a look at some of the features that make Eiffel remarkably different from all other methods and languages, and to put right a few of the things that some people misunderstand about Eiffel. To see more about how Eiffel relates to other technologies that you're currently using or considering using, you can view the other technology-specific presentations in this series.